VTP Versions * VTP version 1 to VTP version 1 supports the following features. The default for old Cisco switches, VTP Transparent Switch Relay. VTP messages only if the domain and version found in the message are equal to its own. It supports only the normal VLAN range 11005. Even in transparent mode. It drops unknown TLVs, type length value, asterisk. VTP version 2 to VTP version 2 has the following improvements over version 1. The default for modern Cisco switches, VTP Transparent Switch Relay. VTP messages without inspecting the domain name and version number. It supports extended VLANs range 1006 to 4094 in transparent mode. When new information is received from VTP messages, consistency checks are not performed. If the MD5 digest on a received VTP message is correct, the information is accepted. It relays unknown TLVs, type length value, asterisk VTP. Version 3 VTP version 3 has many important features and improvements over V1 and V2, such as it supports the extended VLAN range VLANs 1006 to 4094 in advertisements. V1 and V2 only work with VLANs 1 to 1005. It supports private VLANs. Private VLAN is a technique to partition a single VLAN into isolated sub-VLANs. It supports advertisements for multiple spanning tree, MES-T information. It supports enhanced authentication. Passwords can be configured as hidden or secret. It supports the option to turn off VTP in V1 and V2. You can only set the VTP in transparent mode but cannot completely switch it off. It has greater control over the VLAN database through the concept of VTP primary server and VTP secondary server. It solves the revision overwrite problem that exists in VTP version 1 and VTP version 2. Even if a rouge switch is connected to the network as a VTP server with the same domain, password, and higher revision number, it won't overwrite the VLAN database because it won't have VTP primary server privileges. These are given manually by a network administrator. VTP Revision Number switches use the VTP Revision Number to keep track of domains' VLAN database changes. It starts from 0, and for every change, VLAN added, VLAN deleted, etc., the number is increased by 1 and is advertised to all other VTP clients in the domain. Therefore, all switches in a VTP domain must have the same revision number at any given time. If a switch receives a VTP message, it only processes the data if the revision number in the update is higher than its own. VTP pruning. When using VTP, all switches have all VLANs because VTP synchronizes the VLAN databases of all devices in the domain. If, for example, a network topology has 100 VLANs, every single switch has these 100 VLANs in the database and allowed on the trunk links, and every switch receives bum frames from all VLANs. But what if there are N clients and only 3 VLANs? Why? Does the switch need to receive broadcast frames from the other 97 VLANs and then discard them because there are no N clients in these VLANs? This is wasting available bandwidth and resources. That's why the feature VTP Pruning has been introduced to solve this suboptimal resource usage. VTP Pruning restricts flooded bum traffic on trunk links that lead to switches with no clients. In particular, VLAN Figure 1 shows a network topology without VTP Pruning enabled. PC1 is sending a broadcast frame in VLAN 20. Note that there are only 3 N clients connected in this VLAN PC1, PC2, and PC3, but the broadcast frame floods to every switch in the network, even though SW2, SW3, CS4, and SW6 have no clients. In this VLAN.*** Figure 3 shows a network topology using VTP and VTP pruning enabled. PC1 is sending a broadcast frame in VLA 20. Note that the broadcast frame floods only to those switches that have clients in this VLA and SW1, SW5, and SW7. VTP pruning has removed this VLAN from the trunk links towards the switches with no end clients. **VTP pruning needs to be enabled on a single VTP server and it becomes active for the entire VTP domain.